Work, energy and power. So this is the topic heading, and today we'll discuss about the work. So what is the work? This work is different as compared to the normal routine work. So the word is used to describe any activity in which muscular or mental effort is exerted. But in physics, the word work has a special meaning. Work is done only when the force is acting on a body and produces motion in it in the direction of the force or in the direction of the component of the force. So it means the displacement or motion of the body is necessary for the work is in the physics. So what is the work? Work is done only when the force is acting on a body, when the force acting on a body produces motion in it the direction of force. Now obviously the displacement is necessary for the work. Condition which must be satisfied for work done are: first, a force act on a body. Without force work is not possible. A force is act on a body. Second condition, the body must be displaced from one position to another position. The body must be displaced the body must be displaced from one position to another position. Measurement of work. How we can measure? We can measure with the help of definition just we have discussed now. Is what? Work is equal to force into displacement in the direction of force. Force into displacement in the direction of force. Okay, so we can make in the mathematical form: work done is equal to F into d cos theta, where F is the force and d cos theta is the displacement in the direction of the force. So suppose this is your displacement and this is the direction of the force, and also we take a component of this displacement in the direction of force is d cos theta. So this is very clear. The F d cos theta means d cos theta is component of the force in the direction of, and similarly we can make another forms is here: W is equal to d into F cos theta. It means it is clear, force displacement in this direction and the force in this direction, we take a component of the force in the direction of displacement. So F cos theta is in the direction of displacement. Let us take some cases. Case first, when theta is equal to 0. So if theta is equal to 0, the maximum positive work is done is maximum positive. It means F into d, where cos 0 is equal to 1, so it will be maximum. Similarly, in case second, theta is equal to 90 degree, the work done will be 0. Because the cos 90 is equal to 0, and in this case cos 0 is equal to 1. So this the work is 0 when theta means angle between them is 90 degree. Now the third case when we discuss is what? When the displacement and force are in opposite direction. So case third, theta is equal to 180 degree, so W is equal to minus F into d, or we say negative work. In this case the force and displacement are in opposite direction. That's why it is negative. Let us take some example. First example, if a body is moving horizontal direction, the work done by the force of gravity will be 0. Means the displacement in this direction and the force due to gravity is downwards mg. Angle between them is 90 degree. That's why the work done is 0. Similarly, one more example we can take is your circular motion. So what will be, if a body is moving on a circular path, then work done by the centripetal force will be 0. So if body is moving in a circular path, then the displacement or the direction of the velocity is this one. This is because, as we know, we have discussed, the direction of velocity and direction of displacement are in the same direction, and the force are here always towards the center. We say centripetal force, and angle between them is 90 degree. What is it? Is a 90 degree. So theta is your 90 degree. So angle between them is 90 degree. That's why the direction of centripetal force is towards the center, and the circle and the displacement will be along the tangent. So angle between them is 90 degree. That's why the work done is equal to 0. Now units of work done. There are many units. We'll discuss step by step. First, CGS unit. CGS unit is dyne into centimeter. CGS unit, dyne into centimeter. Also we say erg. Similarly, SI unit. SI unit is Newton into meter or joule. Newton into meter, we say joule. Relation between them. So units of work, SI unit is Newton into meter is equal to joule. Newton into meter is equal to joule. 1 joule is equal to 10 raised to the power 7 erg. Now gravitational unit of work. Gravitational unit. Gravitational unit. First in CGS is what? Gram weight centimeter. CGS unit is what? Gram weight into centimeter, and 1 gram into weight into centimeter is equal to 981 erg. Similarly, for SI unit, 1 kg weight into meter. Kg weight into meter, and 1 kg weight into meter is equal to 9.81 joule. Okay, so these are the units of work done. Now let us discuss some positive work and negative work. At which place the work is positive and at which place work is negative. So it is very simple from the formula. The positive work, positive work. In positive work, so in positive work, theta is less than 90 degree. Theta less than 90 degree. We say acute angle. Acute angle. But in the case of negative work, the theta is greater than 90 degree or obtuse angle. So two work done is possible: positive work done and negative work. Energy. When a man does a work, he feels tired. He feels that he has lost something which he must regain to work. A weak man gets exhausted after doing only a small amount of work. A strong man can continue to work for longer duration. Something that a working man loses is called energy. So this definition is also, or this concept is also utilized when the work is converted into the energy. So capacity of doing work or total work done by a man or by an agent is called the energy of the man or the agent. So what is the capacity of doing work? So this is the definition: the capacity of doing the work, capacity of doing work or total work done by a man or total work done by a man or by an agent is called the energy of the man or the agent. Is called the energy of the man. Unit of energy is the same as the unit of work because work is converted to the energy. That's why units are equal. So unit of energy is same as the unit of work, but one unit we consider here is very important, is in the domestic purpose, is what? Kilowatt hour. Kilowatt hour, and the full form is what? Kilowatt hours. So this is we say 1 unit of or electricity board, unit of domestic or electricity energy. unit of domestic or electricity energy. So how this energy is converted into the joule, let us see here. 1 kilowatt hour, watt first is converted into the kilowatt, is converted into the watt, so 1000 watt. Now hours is converted into the seconds, so first converted into the minute and now in second. So 6 into 6 36, so 3.6 into 10 raised to the power 6 watt into second, and we say this is watt. 3.6 into 10 raised to the power 6 joule. Okay, so 1 kilowatt hour is equal to 3.6 into 10 raised to the power 6 joule. One more forms also, this is also the unit of energy is what? Electron volt. Electron volt. So the energy of an electron when it is accelerated by a potential difference of 1 volt is known as 1 electron volt. So what is the energy of an electron? This is what? The energy of an electrons, the energy of an electron when it is accelerated, by a potential difference, potential difference of 1 volt is known as 1 electron volt, is known as 1 electron volt. So again we should know the conversion of 1 electron volt is equal to 1.6 into 10 raised to the power minus 19 joule. This is very important. 1 electron volt equal to 1.6 into 10 to the power minus 19 joule. Now different forms of energy. Number 1, heat energy. When we burn coal, wood or gas, heat energy is released. Second one, light energy. It is a forms of energy which gives us the sensation of vision. Third, sound energy. Fourth, magnetic energy. Fifth, electrical energy. Chemical energy. Seventh, solar energy. Eighth, nuclear energy. Ninth, mechanical energy.